like relatable to our next lesson in pre-final, which is the percent composition. But let's subdivide it for the time being, para we will not be confused of how to understand our lesson for today. So we are now going to focus on the laws of matter, and these three laws of matter class is uh, shall we say that these laws ignited the idea of John Dalton to generate the so-called atomic theory, the five tenets in the atomic theory. But what are these tenets? It's just simply derived from the three laws of matter. Okay, so let's have a quick review of um, not this one. So these names are not basically found in your modules. I will not deal with that one. We'll talk more of these as we proceed with the discussion on matter. So we have here the three laws of matter that we are going to discuss for today. The first law is actually the law of conservation of mass. It's not the definite proportion. The one in your module is the law of conservation of mass. No? Um, this is in connection with the gas laws, the law of conservation of mass. The second law is the law of definite proportion, and the third law is the law of multiple proportions. I will present pictures and you tell me, but I will not answer it yet. You'll understand sooner or later as soon as we discuss the three laws. This picture class, um, this is a composition of two atoms, no, of two different elements, three atoms of two different elements, and four atoms of two different elements. No? Let's say that the one with gold is gold element and the one with the green is green element. Similarly with the next one. So what do you think does the picture signifies between the three laws? Is it the law of definite proportion, law of multiple proportion, or law of conservation of mass?
Mass?
Mass according to Edson, was it Edson or Allen?
Me, sir.
Ah, it's Allen. So how about the others? Edson. Let's compare the answer of Edson. Edson is going to answer the law of
Mm, maybe same with Allen, sir.
the law of mass. Okay, the
Yeah,
law of
love
conservation of
mass.
mass. Probably because thank you, Alan and Edson. Probably because I presented the math. We- That's way. That's where we get to say that your answer is the law of mass. Huh? I tell you it's wrong. Law of conservation of mass is not defined by this picture. Okay, so it could be either the law of definite proportion or the law of multiple proportion. So this one with two different atoms or two different elements, we have the first one is hydrogen, the other one is oxygen, and it will chemically combine to produce the molecule of water called H2O. So what do you think is this pertains to? Nana po yung Mas, Allen, and Edson. So, kung saan naman said na eh. Let me ask a girl this time. Ah, Alona, what do you think so? Is this law signifies?
Law of definite proportion.
Law of definite proportion? Probably. How about Lucia? Let me get back to you on that one, Alona. How about Lucia? What do you think is this law then? Same. The same, the law of definite proportion. I say the answer is wrong. So this is between the law of multiple proportions and the law of conservation of mass. Last again. This picture. So we have here percent by mass of both. One is cultured in a lab, the other one is naturally mined. If you were able to read this in the module, you can answer this one already. So, wala pa nasakto ninyo ha, so far. Let me ask another person to answer. What law is this one? Vince Ahira, what do you think is this law, Vince?
Definite law, sir.
Definite
Is that
law or law of
law?
definite proportion?
Yeah.
James, thank you, Vince. How about James? Would you like to agree with Vince?
Uh, yes, sir.
Okay,
The law.
kan classmate talaga, no? Yes, sir. I will agree with Vince. Classmate
No,
talaga.
actually,
Sabayan to ano
I'm
to?
not sure
Speech
if
choir. Okay. For the first time, thank you, James and Vince. For the first time, you're right. This is law of definite proportion. Again,
yeah.
this is law of definite proportion. Notice that what was cultured in a laboratory and what was mined naturally have the same proportion with respect to oxygen and sulfur. Even if they don't have the same mass, but probably even if they don't have the same place to where they are found out, but still the proportion of oxygen and sulfur is definite at 50-50. Thus, this is considered to be under the law of definite proportion. Let's go back to the picture a while ago. This one. This one is a combination of two the same elements, but it could be that the two elements could have different number of atoms in a given compound. For example, ato lang taga nag-example na siya ha. This is probably carbon monoxide, one carbon and one oxygen, assuming. But this one is carbon dioxide, one carbon atom and two oxygen atoms, carbon dioxide. If in case there's a carbon trioxide, then let's name this as carbon trioxide. Okay? So this feature class showcases the law of multiple proportions. Huh? They are composed of the same elements, but they have multiple proportions with respect to the molecule being present. Okay. The law of multiple proportions states that one atom is constant or fixed, while the other one varies from time to time, depending on the amount or depending on the ratio or the proportion of that said atom present in the molecule. Whereas this one is the law of conservation of mass. You'll notice the law of conservation of mass class because um, what happens here is that the mass of the elements in a reaction will just be the same mass of the final product. Like oxygen is 16 and hydrogen is 2.02, which if you add, it will result to 18.02, which is the mass of the final product. And that is the literal definition of the phrase conservation of mass. If we have a rule in we have the what was that in energy? Energy is neither created nor destroyed, di ba? Do we have that in physics? So as with chemistry class, matter mass of matter is neither lost, neither created nor destroyed. It's just transformed from one mass to another. At this point, it was just being combined from a single mass of oxygen to a single mass pertaining to hydrogen. It is now going to represent a single mass of the compound of water. So this is the law of conservation of mass. And this one is the law of definite proportion. What about this one, class? Someone siya. Balloon at room temperature and balloon heated up. So, nanata itong tulo ha? Nanata example sa tulo. Law of definite proportion, law of multiple proportion, and law of conservation of mass. And I'm sure you will not answer here the law of conservation of mass. Okay, ang additional clue ninyo, if that is the law of conservation of mass, there's a reaction. Okay, so what do you think so is this law? What does this law signifies? Let me ask Christopher.
Um, is it another law of definite proportion?
Law of definite proportion. Thank you, Christopher. Would you like to agree on the answer of Christopher, Sean? Is this the law of definite proportion?
Um, yes, sir.
Yes, sir. Okay, so if Sean agrees to the answer of Christopher and Christopher says that it is the law of definite proportion, probably there's a reason behind it. Okay, thank you, Sean, and thank you, Christopher. The answer is actually correct. Okay, Christopher and Sean are correct. In fact, this tells us the number of atoms present in the molecule inside the balloon. If you look at it, there are exactly 7 atoms, 7 gaseous atoms present in the deflated balloon, whereas there's still that 7 atoms present in the inflated balloon. No, whether it is inflated or deflated, it's just the motion of the atoms of that said air that makes the balloon either inflated or deflated. What do you think so is the reason? This is out of the topic, but what do you think so is the reason behind why the right illustration is inflated? Edson, what's the reason behind this one, Edson?
Maybe because the heat of the um heat inside the balloon wants to expand.
Mm-hmm. Okay, so let's put it this way. There's a change in temperature. If you look at it from the, thank you, Edson, by the way. So the answer, Edson, is talking about heat. Yes, indeed, it's pertaining to heat. And from the room temperature, let's just say 37 degrees Celsius, it was then heated up and it probably raised into 100 degrees Celsius. So the balloon then inflates. So why is there an inflation? Because temperature increases. And when temperature increases, what do you think will happen to the molecules of the air? It will be excited. Bangga na sa walls of the balloon. It will it will generate more kinetic energy. And the generation of more kinetic energy allows the volume or the surface area of the balloon to expand, generating a bigger volume of the balloon inside. But if we let it cool down, it will then um, deflate at some point. Motorcycle riders, Edson, I don't know if the others know how to drive a motor. Um, you know to drive a motor, Allen? Allen and probably Alona. Katig drive ni si Alona. Anag kini mo drive si Alona. Dili katig drive, wala. Okay. Edson, I think you can relate to this one, Edson. If your motorcycle is not being used, what happens to the tires of your motor?
It's more like deflates it.
Humilis, di ba?
Mm.
Right. So, maski nagwa na to nagamita, but since the temperature cools down, the molecules of air inside in the rubber tubing tends to para bang hindi siya ma-excited. So, it tends to deflate the said it tends to deflate that said rubber tubing. Mo na mo muhiyos yun po siya. That is basically the reason why we have this being inflated because heat excited the molecules of the air inside in the balloon. As molecules is excited, the kinetic energy rises. No? Bako yung kinetic energy. That's how much with that. Let's proceed with the Dalton's atomic theory. Dalton's atomic theory, as developed by John Dalton and revived by Democritus, states 5 major tenets. What are these 5 major tenets? You can follow this in your module. The first tenet here is all matter is made of an extremely small particles called atoms in constant motion. Okay. This is the average This is the average kinetic energy of the molecules of a said matter. For a solid matter, the molecules are constantly sticking to each other. For the molecules of water, they are sliding past each other. That's why one of the idea of water or one of the properties of water is fluidity, and the ability to slide past each other makes it fluid, the ability to flow. And for gas, it's just simply bouncing, or bumping, slide past each other. Magkabangga na sila. Second theory of Second theory, according to John Dalton, atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Okay. The third one, atoms cannot be subdivided, created, no, or destroyed. You cannot divide it, you cannot create it, you cannot destroy it. Atoms are the indivisible um, these are the indivisible matter present in a certain element. That is why how can you call an element and not a compound? How can you call a copper? Do you have seen a copper wire? How can you say that a copper wire is an element and not a compound? It is because copper is indivisible. You cannot destroy that since it is composed of only one atom of copper, which is indivisible, cannot be divided, cannot be created, cannot be destroyed as well. No? The destruction perhaps of the molecules of that atom will generate nuclear energy. No? It will generate a nuclear energy via nuclear fission. For planet, atoms of different elements combine in simple whole number ratios to form chemical compounds. We will soon understand what this atomic theory means as we move further with our discussion about um, uh, chemical equation. No? Um, Discussing about ang tawag dito? Balancing chemical equation pa lang, okay? As we move forward with balancing chemical equations, we'll then know for sure what this whole number ratio means, okay? Also, in the law of multiple proportions, you'll have to understand what these ratios are all about. And we have here, in chemical reactions, atoms are combined, not separated or rearranged, like the concept of the Lewis electron dot structure. No? Imagine the molecules of water, which is arranged in a straight pattern. But you can't arrange the molecules of water in a straight pattern because there's a lone pair of oxygen that is not bind or that is not creating a covalent bond to hydrogen. Therefore, it is slightly bent. No? So you can rearrange the arrangement depending on the electronegativity of that said molecule. Speaking of electronegativity, as the elements in the periodic table goes to the right, the electronegativity increases. No? As the valence electron increases, the electronegativity increases. I hope that you have with you a periodic table right now, or I do hope that you already have purchased a periodic table so that you will be guided on our discussions. Sinong may periodic table na dito, class? Meron na ba tayo? Because in as much as I want to let you buy now, so you cannot go out of your house, right? Because we are in the session. So probably this weekend, feel free to go to the I don't know if you are allowed by your parents, but ask your parents to buy you one, since this is really helpful in our next succeeding lessons, especially if we are going to talk about percentage composition. Okay, so these 5 tenets class are probably not verbatimly spelled out in your module, but at some point they're just the same with your module. Okay, so let's talk about the first law in the conservation, first atomic law or the law of matter, the law of conservation of mass. It is according to the third and the fourth tenet. Third and the fourth tenet is atoms cannot be subdivided. Then the elements of a whole number is expressed in ratios for whole numbers. So we have here, atoms cannot be subdivided, it cannot be created, it cannot be destroyed, but they can combine. They can combine. As mentioned by the picture a while ago, two molecules of hydrogen, one molecule of oxygen, it combines to form the molecule of water called H2O. And then similarly, if we have here point number 4, in chemical reactions, atoms are combined, separated, or rearranged. So this is now the fourth or fifth tenet pala. I think this is not the fourth tenet, but the fifth tenet in the atomic theory. So atoms, in a chemical reaction, atoms can combine. I think I mentioned this one when I point out number 3. Atoms cannot be subdivided. It can be created, but they can combine. And we call this combination as chemical reaction. Okay. Point 1 perhaps pertains to the gas laws. Okay. All matter is made of extremely small particles called the indivisible atoms. Okay. And then point 2 or tenet number 2 tells us about the law of definite proportions. Atoms of a given element are identical in size, mass, and other properties of atoms of different elements. So if you notice in the previous picture, even if the molecule is cultured in the laboratory or the molecule is mined naturally in the earth, they have an identical size, identical mass, and identical properties, isn't it? I forgot what is the name of that molecule, no? But it was composed of 50% oxygen and 50% what's the yellow one? Sulfur. And point number 4, no, is going to pertain to the law of multiple proportions. The law of multiple proportions is now going to showcase that in the same or in two different elements, they contain whole number ratios. It could be 2 is to 1, 1 is to 2, 3 is to 2, 1 is to many, and the like. So this is where we get to explain the 5 tenets in the Dalton's atomic theory. Number 1 is gas law. Number 2 is definite proportion. 3 and 5 is conservation of mass. And tenet number 4 is multiple proportions. So the 3 laws again is simplified by the general picture of what Dalton's atomic theory. There are some other inputs that I did not include in Dalton's atomic theory, that, like the history of the discovery of the protons, electrons, and neutrons. So I'm not going to discuss it further. I hope that it's not found in this module, in this presentation, but I will not discuss it further because I think that was a topic when you were still grade 8 or grade 9. No, like who discovered the electrons. No? Sino makakapagsabi, sino nag-discover ng electrons? +1 sa chemistry. Tatlo lang mga tao na yan. Si Ernest Rutherford, J.J. Thomson, o si James Chadwick. Tulo man na sila. Usa na nila electron, usa na nila proton, usa na niya neutron. But before it was called protons, electrons, and neutrons, J.J. Berzelius or Johannes Jacob Berzelius named these molecules as alpha, beta, and gamma. Positive, negative, and neutral molecules. But in the advent of the discovery of these people, they tend to rename these rays as the particles of the indivisible atom as protons, neutrons, and electrons. So the theory of Dalton was accepted because it explains what was seen, and it did not give away to determine the, but it did not give away to determine the molecular formulas. Speaking of molecular formulas class, we have three ways in which a compound is to be named: molecular formula, empirical formula, and structural formula. With respect to structural formula, that is done with respect to how the molecule is drawn, to understand how the bonding exists. That's structural formula. When we talk about molecular formula, it's the exact number of atoms present in the molecule. Empirical formula is the simplified formula wherein all the subscripts of all the subscripts of the molecule is divided into simple values. For example, the molecule of glucose. What is the molecule of glucose? What is the molecular formula of glucose? Sino makapagsabi na sa akin dito? Si Miguel. Tanungin ko si Miguel. Kasi alam ni Miguel. Miguel Apale, what is the molecular formula of glucose?
C6H12O6.
Very good. C6H12O6. That's the molecular formula of glucose. Thank you, Miguel. But when you talk about the empirical formula of glucose, pwede rin nato na siya i-reduce. Instead of saying C6H12O6, we can represent the molecular formula of glucose as CH2O, which means 6, 12, and 6 are now divided by their common denominator, which is 6. So therefore, we can express the molecule of glucose as CH2O. Okay? Or C1H2O1, something like that. And then I think this is in your module class. You can see this in your module, right? Nasa in your module. O sa may nasa right, sa left. The one with the yes. Can be separated physically. What is that in the right? I think that's
Hetero?
hetero.
Hetero?
The general. The
Wait.
general one, being hetero and being homo. What is it?
Mixture?
Very good, mixture. And what is on the left? You cannot separate it physically. It's
Compound?
Substances.
pure
Mhm.
substances. Very good. Pure substance. So that is also one of the items that was stressed out in the activity sent by Sergio in the first module. The separation of the following, either physical or chemical. If you can separate it physically, you call it mixture. If you cannot do it physically, rather you can do it chemically. This is a pure substance, no? So under mixture class, if you have a uniform phase, for example, seawater, um, um, soda, what is that under mixture? Under the yes column or box.
Homo?
Homo, very good. And then if you have no uniform phase, where you can see multiple faces, that is heterogeneous. Siguro isali ko na lang yung yung mga ganito sa ano no, yung first module ni Sir Joe, ibabalik ko sa midterm para ma-perfect ninyo kung midterm ni QE. Well, it depends on me because I'm the one who is going to make the exam. Okay, what about pure substance class? If you can separate it physically, how will you call? Rather, if you cannot
Compound?
separate it physically, but you can separate it chemically, that is a compound. Very
Compound.
good. But if that is no chance of separating it chemically, that is already the simplest of which, and it is an element. That is why in the phrase that I said a while ago, why is copper an element and not a compound? Because copper cannot be separated chemically. Okay. We have examples for this one. We have air for homogeneous. No. Granite for heterogeneous. Water for compounds. And iron for elements. So these are some of the examples of what we have under the classification of matter. Okay. Let's proceed with your module class because um, let's proceed with your module. I think there's something. Sir, can I ask a soft copy of the module, sir? What you don't have a copy right now, Lance?
No, sir. Okay.
Sige, I will.
Available na daw.
Oh, yeah. I remembered. Your module was actually given to Miguel Apale because um, Miguel Apale's module bag was not including there the chemistry, and then Ma'am Zen failed to remember again that Miguel is part of the grade 11 general chemistry one. So your chemistry module was given to Miguel. So I'll just give you right now that for a while. What's your name in Facebook, Lon, or Messenger? Merif Cintillas, this one? Ay, you chatted pala. Sorry, Lons. Blame it all to Miguel. Charot. Okay, I sent already a file in Messenger, Lons. Do you have a printer in your house? Just print it na lang if you wish to have a hard copy. Okay, thank you. So I hope the others already have the modules with them. Now let's go to your module class. How will we understand further the three laws? Because the Dalton's atomic theory is just the capsulated explanation of the three laws of matter. No? So we have here the anong tawag nito? The further explanations of the theories above. We have elements that are composed of indivisible atoms. Atoms are alike in a given element and the likes. So let's first go back to the law of conservation of mass. So law of conservation of mass states that the total mass of the material present in a chemical reaction is the same as the before reaction. In other words, whatever the mass of the elements, if you just add them all, it's also the mass of the compound. For example, here class, in the first example, carbon is 1 grams, oxygen is 2.6 grams. So expected that in the final compound, the carbonic acid becomes 3.66 grams, the sum of 1 and 2.6. Okay? Assuming that I am going to delete the mass of oxygen here, class. Okay. Assuming that I deleted the mass of oxygen here, what do you think so will be the mass of oxygen if I write here X? What is the value of X knowing that the compound is 3.66 grams and carbon is 1 gram? A simple subtraction will do, class. 3.66 minus 1. So therefore, this is 2.66 grams. So it's just as easy as that, class. If you look at it as a problem later on, because there is a problem here wherein I gave the mass of the compound and you're going to find the mass of one element or wala pala dire. For example, here, I will mark the mass of selenium as X, something like that, huh? This is just an example. If I'll make the mass of selenium as X, and there is a mass of the compound, which is 4.82, and phosphorus is 1 gram, so just simply subtract 4.82 grams by 1 gram. So this will be 3.82. So that is the simplest, not that elaborated understanding of the first law as being mentioned by Antoine Lavoisier. The first law states that the total mass of the material present after and before the reaction are just the same. Okay? So the law of conservation of mass as well is an outlet to percentage composition, which we're going to discuss in pre-final. So after this lesson, we'll proceed with percentage composition, then chemical reaction diagram. Okay. And I think the chemical reaction, if I'm not mistaken, Miggy, is the start of stoichiometry. You had stoichiometry in the grade. We had stoichiometry in the grade 11, right? What is it? General chemistry 2? Was it chemistry 2, Miggy? Are you were you my student in chemistry 2?
Chemistry 2 was in second semester, sir, di
Yeah,
ba?
second semester, yes. Nakalimutan si Miggy. I think I did discuss percentage composition somewhere in the last part, no, pre-final or final, which will also be our lesson before we go with organic chemistry. As we move forward with understanding of inorganic chemistry, we start dealing with stoichiometry after this lesson. Okay, so that is the law of conservation of mass. Question regarding the law of conservation of mass. You can consider some errata. We cannot call it errata, but we can call it percent of error in a certain chemical reaction. For example, here, the mass of hydrogen is 2 before the reaction, and then oxygen is 10 grams before the reaction. So expected that that water before the reaction will be 12 grams. But after the reaction class, water is just 12.26 grams. So there was a 0.74 grams of water left after the reaction. In cases like this, we call this in stoichiometry as limiting reactants and excess reactants. Okay. Again, this is limiting reactants and excess reactants. How will we understand limiting reactants and excess reactants? Again, percentage composition as ta. Balik na sa test percentage composition. So to understand again what am I mumbling about right now, I hope that this law, conservation of mass, is understood in full details. Para when we discuss the next lessons to come, it's a smooth discussion of the lesson there. Questions, clarifications? I hope that our chorus with Sir Sim and MLB does not distract your understanding with the lesson. Can you hear MLB and Sir Sim? Ay, wala. Ooh. Uy,
Yes.
some of you guys here, some did not. Okay, so I tinatamad akong pumunta sa ibang lugar, class. Pasensyaan nyo na, dito na lang ako kasi nakaupo lang ako dito. Let's proceed with the law of definite proportion. The difference between the law of definite proportion is the total number of molecules present in a given compound. So when you talk about definite proportion, whether it is naturally occurring or cultured in a given laboratory, they will all but have the same, or not cultured, but synthetic sample or natural sample, they will just have the same percentage composition. Perhaps we don't cater much on the idea that there are other additives aside from the element itself. But when we get the percentage composition of that element present in the said compound, it will always end up with the same percentage composition. Like when I did mention a while ago, the molecular formula of glucose, which is C6H12O6, and the empirical formula of glucose is CH2O. That perhaps tends to associate law of definite proportions, right? But if we look at it in its percent composition by mass, they still have the same percentage composition of carbon, hydrogen, and oxygen. Thus, it still follows the idea of law of definite proportions. Okay. So let's have here as an example class. Now, we changed the mass of sulfur to from the first experiment as 1.56, the second experiment as 3 grams, and then the third experiment, we changed the mass of lead to 18 grams, but sulfur stays at 1.56. After generating the final product, which is lead sulfide, with the same mass, of course, this falls under the category of law of conservation of mass. 10 plus 11, 10 plus 1 is 11, 10 plus 3 is 11, 1 plus 18 is 11. No? 1 plus 18. Yeah, because there is an excess reactant of 8 grams from lead. So instead of 18 grams in the final product, there's an excess reactant of 8 grams and still generating the mass at 11.56 grams from the first three experiments. And looking closely to the three experiments, we have the same percentage composition of lead and sulfur all throughout the three experiments. Three experiments. Thus, this tells us that even if we add or subtract the proportion or the mass of one matter to or one element to another, it will still give us the same percentage composition in our end compound. Thus, this is telling us the law of conservation of, or rather, the law of definite proportions. And again, the law of definite proportions goes back to percentage composition, and this is the formula for percentage composition class. Have it remembered because when we talk about percentage composition, dali rin nito siya masabtan. Talking about percentage composition, para it will be clearly understood what is the law of definite proportions really means. Let's try to find the percentage composition of the elements found in muriatic acid. What's the molecular formula of muriatic acid? Muriatic acid is hydrochloric acid, no? HCl. Sa'yo naman na. HCl. This is the molecular formula of, why is it that is C? Yeah. So the molecular formula HCl or the muriatic acid has one atom of hydrogen and one atom of chlorine. So if we look at it in percentage composition from the formula, mass of the oxygen divided by the mass of the compound. So when we look at the percent composition of, let me copy this one. So we look at the percentage composition of hydrogen from here. So let's change this to hydrogen. So let's find the mass of hydrogen divided by the mass of the compound. Mass of hydrogen is 1.02 or 1.001. What is the mass of hydrogen in your periodic table? We have 1.007 to 1.009. So let's try the average mass of hydrogen, which is 1.01, divided by the mass of the compound. Hydrogen plus chlorine. Chlorine is 35.45. So 35.45 plus 1.01 is equal to 36.46. So we divide 1.01 by 36.46 and multiply it by 100. So 1.01 divided by times 100, you'll get the percentage composition of hydrogen in muriatic acid as 2.77%. Similarly, if we're going to find the percentage composition of chlorine, so the percentage composition of chlorine, spell chlorine, CHL, is mass of chlorine divided by the mass of compound. And then the mass of chlorine is 35.45. So there's 35.45 divided by 36.46 times 100. You'll get the answer 97.23. Okay, so notice class that if you add 97.23 and 2.77, it will equate to 100%, the total mass of the compound. Similarly, if you add 86.5 by 13.7, that's also 100. If you add 27 and 72, that is 100. 42 and 57, that is 100. And then so on with 88 and 11.2, that is 100%. Similarly to this one, it will also equate to 100%. So you'll know that your percentage composition is wrong by the time you add all the percent value, it will give you 99.7%. So that your answer there is perhaps wrong, or something is wrong in your percentage composition solution. Okay. With respect to the mass of the elements, that is the goal of how percentage composition looks like. For example, here, we know that carbonic acid is 27.29% carbon and 72.71% oxygen. So when we talk about a 5-gram carbon, how many grams are there present in the said, or how many grams are there in the compound? Since 5 grams is 27.29% of X, so it's like finding the value of the base in a percentage base rate solution in basic mathematics. No? So the percentage composition can be used as a formula to find the mass of the compound. So if you are going to cross multiply the formula, it's like replacing mass of the compound by percent of carbon and percent of carbon by mass of the compound. Magbaylo ra sila, as in the case of this one and this one. No? So you can now determine the answer by simply going back to the formula, which is this one. Mass of the solute or solvent divided by mass of the compound. Law of multiple proportions states that if two elements form more than one single compound, the masses of one element combined with the fixed mass of the second are in the ratio of small whole numbers. So for example, here class, our fixed element here is carbon. So it's basically in law of multiple proportions, we may eliminate the fixed element, because if we look at it as the like in this problem, carbon is fixed, so we just have to consider the carbonic acid and the carbonic oxide as our two masses to be equated, so the ratio ends up with 2:1. No, in every carbonic oxide there lies 2 carbonic acid, something like that, the ratio. No, and also here the mass of iron is fixed, so we can just eliminate the mass of iron. We can equate the mass of chlorine in ferric chloride and the mass of chlorine in ferrous chloride. If in case one is fixed, so we can equate, or we can find the ratio of the other element present in the said compound directly. Just like in the example here, class, we have um, the mass of oxygen and hydrogen peroxide and the mass of water, the mass of oxygen in water. So you can eliminate mass of hydrogen. You just have to find the ratio of oxygen and hydrogen peroxide and oxygen in water. So this over this will be your final answer. So to further understand number 5, we'll just have to wait for Thursday. Let's see if you can come up with a good answer in the 5 items that we have here present in that module. 5 lang nakabuok ha, gamay ra na siya ng inyong ansiran. Ang inyo lang, you have to answer it well, answer it correctly, read it properly. There's a challenge question that follows, number 5. What is the formula for hydrogen peroxide? That is a famous formula, and I hope you can find that in the internet, because I do believe you'll just simply search that in the internet. We end at 1:30. We will end at 1:30, right? And the time is already 1:32. Sino yung walang score kanina? Sino yung walang scores kanina yung tinawag ko?
Allen, sir. Allen.
Allen. Do we have Allen here? Allen. Allen Ikurasora. Allen. Saan ka na, Allen? Allen. Ay, nako.
Yes,
Back to
sir.
you, Sir Jet.
Sir,
Never mind,
sir.
zero na ka.
I was urinating, sir.
Ay, sorry. Okay, so I was actually asking your classmates a while ago of their answers, or rather their scores in the 1 to 50 online exam for conversion. What was your score there? The day 2 in the performance
I
task.
was 14. Oh, yeah, I was 14, sir. I
Can you
lacked 0.
can you send me the picture?
Wait, sir. I'll go to the Edmondo, sir.
You send it to me in the Edmodo. You try to
Yes.
after I end the call, find a time and send me the picture of your score so that I can record it. Okay.
Sige, sir.
Okay. So thank you for your attendance today, class, and I hope you learned something about our lesson as of today. See you Thursday for the checking of the 1 to 5 activity in our module. Goodbye, everyone. Lons, you just have to print your own module na lang, Lons, ha? Thank you, Lons. Bye-bye.